Welcome to Lesson 4, Decisions. Decisions are important to a program because it gives the program the ability to be intelligent, which now connects to the second part of the title of the course, which is intelligence. So if you recall, variables represent the concept of information, while decisions represent the concept of intelligence. With decision making, the program can now decide what to do on its own. So we'll be discussing the structure and not connected to a circuit playground and a more just traditional, just information examples. The next lesson, topic 2, will now connect it with the circuit playground. But let's get to it. So in this example, I want to cover the concept of maybe an average and being able to display whether the person passed or failed. So let's create 3 integer variables. We'll say G1, G2, and G3. And now let's create a variable float called average. And I want to do something a little bit different because we haven't had a chance to explore it. The void setup has been sitting there kind of like with no other code other than the circuit playground began. But you can do things in the setup that could be important. For instance, giving values to your variables. So in this section, I'm going to say G1 is equal to 100, G2 is equal to 90, and let's say G3 is equal to 80. Okay. And if we wanted to, we could actually calculate the average here too, which, why don't we do that? So average is equal to G1 plus G2 plus G3. And again, if you recall how to create an average, it's the summation of all the grades divided by 3. Okay. And I'm going to do something, well, let's leave it like that. So, and in our main loop, we're simply going to print out the average. We haven't done a decision yet. This is just a review of variables and mathematical operations. Hopefully you're already kind of spotting there's a slight problem in my program. But I'm going to let it come out in an observation. So let's see. So let's pull up our serial monitor. And hopefully you notice the average of 100, 90, and 80 should have been an easy average. It should have been 90. But we're getting 216. Why is that? Well, the problem here is the fact that order of operations. Division happens before addition. So in order for us to force the computer to have to do the addition first, we have to introduce parentheses. If you recall, parentheses has a higher order precedence of operations over division. So if we do this now, it will add up the numbers and then divide by 3. Let's run it again. And again, this is just review. And there we go. Now we got the 90. Okay. So again, the rules of mathematics have to apply in a programming environment. So just think about what you would have done by hand. But let's get into what we are actually looking to cover, which is how to make a decision. So the decision we want to make is to be able to tell the person whether they passed or failed. And in all programming languages, the word if is used to start that decision-making process. Now, this is a completely new concept. It's not a variable. It's not working with a Circuit Playground Express. This is actually part of the language. This next part is part of what's called the syntax of the command, which means how you write an if statement. So I know up until now we've been associating the fact that parentheses are either connected to a function, such as this, such as a set pencil color, such as the left button, or more recently just now, associated with mathematics. This is neither. This parenthesis is part of the language, part of the syntax of how you write it. So just realize that every time you do an if statement, when you put those parentheses, that's just the way you write it. It has nothing to do with math, has nothing to do with function. This is just part of the language. So what we want to do is, we want to make a decision to decide if average is greater than or equal to 65. The next part is also part of the syntax, is the curly bracket. Right? So these curly brackets let the computer know that whatever goes in here is what I want to do if the average is over 65. So let's take this serial print here, take it out of there, let's put it here, and let's do a nice measure that says, good job. Okay. So we should only see the words good job display if the average is over or equal to 65. Let's see. And we recall that from our current numbers, the average is 90. So we should be able to see the words good job come up. So let's pull up the serial monitor. And no surprise, the words good job pop up because the average is over or equal to 65. Right. So one thing to know is this is a question. So a decision is about answering a question. You know, is this happening? So I would read this part of the if statement as, is the average greater than or equal to 65? So if the answer is yes, then we actually do these statements. This is called the condition. That's part of the if statement. But now let's, for whatever reason, we had, format's freezing again. Let's close this out. And let's say for whatever reason, we had a rough first test and we got a 0. Which again, the average of these three numbers should guarantee us that we have a failing grade. So let's see what happens when we do that. So we're going to upload it. Let's open up our serial monitor. And you might think, oh, wait a minute, is there a problem in the program? Nothing's showing up. Well, if you really think about it, the program's intelligent. We have now made the program intelligent in that it's only going to display the serial print line if the average is over 65, which it's not. So even though this is exactly the outcome we should expect, this is almost, I would consider this bad programming in that now the user's sitting there without any feedback. So there is another part of an if statement that lets us specify what to do if our condition, our question, turns out to be false. And that's called the else statement. So the else statement happens whenever your condition turns out to be false. So if average is greater than or equal to 65, we're going to do this. Otherwise, we're going to do this. So let's say need more practice. Okay. So now we're kind of guaranteed to get one of two messages. If the average is greater than or equal to 65, we get this. Otherwise, else, we'll get this. So let's try it. Let's run it. Let's pull up our serial monitor and we'll see now need more practice. So this is good in that we're able to display some information depending on what the outcome of average is. Now I'm going to go back to the 100 and let's run it again and we should get good job back. So notice, the program's smart now. It knows whether to tell us good job or need more practice, all based off the if statement. So we've now made the program intelligent. Now in the next lesson, we're going to tie this to the circuit playground, and now we're ready to start doing some cool projects. Because we're going to be able to make the circuit playground think on its own, or more precisely, react to different ways that we use the circuit playground, i.e. the buttons. All right, so let's go back to our presentation and let's review what we've covered. So we had a review of variables, mathematical operations, order of operations. In order to get the proper average, we had to put parentheses around the sum, forcing the sum to happen first. We discussed the structure of an if statement, which is used for decision making, and that's across all languages. All languages use the word if to make decisions. A little bit of syntax in the coverage that the parentheses, when used with an if statement, it's not a function, it's not a mathematical operation, but it's simply part of the language. It's just the way you write an if statement. What goes inside the parentheses is something called a condition, which turns out to be a question that you're trying to ask as part of the decision. You know, is the average greater than 65? Now, what wasn't covered in the lesson, but hopefully you can kind of see if something is greater than, you can also check to see that something is less than. But we'll be exploring these other operations that you do with the if statements in future lessons. So get ready, because we're going to be able to start doing some fun things with the circuit playground. Thank you.